exercise from last week, but we can still do a project for today first. So you can go for File, New, Java Projects, and then it's CSE114. CSE114 and Spring 16, and then Week 08, Lab 1. Okay, for today. If you do that, and we're going to do the first exercise first. And in Java project, you can actually create something called packages. So packages is like folders in your computer, just a very convenient way to organize your files. We can try that actually. Let's say if we try to do different exercises in the same projects, you can group them into different packages. Okay, let's try that. You might also find it useful for your assignments. Sometimes if you have more than one classes, you may want to group them into different packages. So now you can say new package. Okay. If you say that, we can say, what about just points? So it's going to be a package called points, and we're going to put the class for the points over here. Okay, called the points. So now we got one package there, and later on we're going to create another package for the second exercise. Okay, so that's just a very standard way of organizing your Java files. Okay, so now let's say for the points, we're going to do a new class. Let's call that point. Okay, just a point class, like that. And we're going to use defined the two attributes for a point on the two-dimensional plane. So it's going to be x and y coordinates. So you can say double x, value of x coordinate, and also double y, value of y coordinate. Okay, so as I mentioned,
I'm gonna be tomorrow.
Oh really? Okay.
Yeah, I gotta see a doctor today.
No problem, no problem. Thanks for coming anyway. All right. Okay. All right. So for this class here, let's create a constructor which will initialize both x and y. Let's say, so we can have point, and we're going to initialize x and y. So let's say double new x. We can call it initial x. Init for initial x, and double initial y. And I'm pretty sure you know how to do the assignments here. So it's assign the value to x attributes, initial x, and also assign to the attribute y the value of initial y. Okay, very standard way of doing things. Okay. Any one of you actually got handouts from last week by any chance? So I don't have to go back and forth with the PDF. Can I have that? Oh. The handouts. No, I'm not. Oh, you don't have one. Okay. I'll print one. I'll print one for you. Don't worry. Yeah. But if you have the handouts, just easier for me. I'll give it back.
I'm not sure if I have.
No, that's okay. If no, that's fine. I can just go back and forth. Yes, exactly. Super. Thank you. So yeah, I'll put a copy for you. Don't worry. It's good that you raise your hand. That's good. Okay, just easier for me. Okay, so we got point, and let's try something here, point tester. So can we go back to the package explorer here, and right click on the points package, new class. Okay, let's have a new class here. Let's call that point tester. Okay, and then we have a main method here. Main method. Okay. So now we're going to try maybe just several points. So let's say P1 to be 0, 2. I'm just following the instruction. So let's say point P1 is assigned to new point. One thing to show you first, what we learned from the lecture. If I simply say point P1, okay, so P1 is of type point, is a reference type, right? Point is a class. So now let's try right away to say system.out.println P1. Let's try that right away. What's going to be that? Remember, P1, actually, Eclipse is actually smart enough. They complain that your P1 may not be initialized. However, you can do some very funny assignment over here. You can simply assign that to null. What does that mean? So here you're trying to say, well, P1 is going to store the address of some point objects. And now I'm saying the address I want to store is null. And now I'm printing P1. Okay, what's going to be? What's going to be the output here? If I try that, it's going to be just null. Just null, right? Just like a null address. Okay, I'm going to do some comments for you. So now P1 is, let me just call it P0. Okay, so I'm going to do P1 for you as well. So I got P0 and P0. Okay, so you can see P0 is going to store the address of some points. And now I'm saying that the address I want to store is just null. It's like a special address, which means it's basically the address of no objects. Okay, if you try that, you're going to see that P0 is null. Okay, let's do some contrast over here. If you say point P1 is assigned to new points, and to be consistent with your handouts, I would say 0, 2. Okay, so now I'm saying P1 is going to store the address of the point objects, and for that point objects, the x value is 0, and the y value is 2. Okay, that's what it is doing. Okay. So now, if I do a very similar line, if I say system.out.println, and I say P1 is P1, at least we should guess it should not be null anymore, because from line number 8, we let P1 store the address of some objects because we have the new keyword on the right-hand side of the assignments. Okay, let's see what's going to happen. If you do that, you have something like this. So basically, that's sort of the address of the point. So somehow includes the class. You can see, first of all, you got points, which is the package we have. Points.points. That's tell you where the class is. At the 785.2E922 is the address. Kind of the address. You might have a different number from mine, but it doesn't matter. Just an address. Okay. So far so good. Okay. P0, P1. So P0 stores nothing, and P1 stores something. And to be even clearer, it's really important to make sure you don't get lost. So now in this case, we say that P0 just point to nowhere, just null. On the other hand, P1 points to an object of type point, in which case we got x and y, and x is 2 and y is 0. 0 and 2. X is 0, y is 2. Okay, so that's P0 versus P1. Okay. Okay, let me go back. So now to actually better print out, let me put some comments for you. Print line P1 only prints the address stored in P1, only the address. If we want to print out the contents of the points, let's say x and y, we need to get access to the attributes. To print the contents of P1, we need to access the attributes. Okay, don't worry, I will give you time to type when I'm done. So system.out.println. So now you can say P1 is, so now let's say we start with parenthesis plus P1.x, the x value, followed by a comma, a space, and plus P1.y, and followed by a closing parenthesis. Okay, I'll give you time to type. If you compare lines 10 versus 12, 10 there simply print out the address of P1. On the other hand, line 12, you try to print out the values of the attributes of P1. So they are different. Let's try that and see what happens. So here you got, see, P1 here is the address over here when you simply print out P1. But here, when you get access to P1.x and P1.y, you got a much more meaningful printout from P1. Okay. Just to reaffirm what we learned from the lecture today. Okay, let's do some, one more thing. Let's try this. Remember P0 simply stores null. If I do the following, what's going to happen? Can I just copy this line here for me? Just this line to print out P1.y and P1.x. Copy that and put it here. Okay, so rather than P1, let's say P0 and P0 and P0. Take a guess. What's going to be the printout from line number 7? Be careful, because we know somehow P0 stores something very special.
The error thing where they point.
Like a null pointer exception. I think that's what we said, yeah. So the problem is, you can see from line number 5, we say that P0 is going to store the special address called null. And null simply means it does not refer to any actual objects in the memory. So now in line number 7, when you say P0.x, there's simply no such objects. How can you get x from? Right? There's no, because you can see the diagram here, it simply just refers to null as opposed to some actual objects. So P0.x is simply undefined. So you're trying to call the attributes on some null objects. So this is like an error at runtime. Okay? But in the compile time, this will compile okay, because P0 is of type points, and x is an attribute of the point class. That's okay. But if you try to run it, null pointer exception, you might run into this quite often in your assignment too, which is quite expected. That's how you learn. Okay? So I just want you to be aware of this. Whenever you see a null pointer exception, that simply means you're trying to call an attribute or a method on an object that is actually null. And actually, when you get this, don't get too terrified. They do give you some useful information. Okay, so now you can try to read it. Exception in main, Java the language null pointer exception. So you know that this is the kind of error you will get when you try to call an attribute or methods on null objects. In the second line there, add. So this tells you where exactly the error occurs. So if you click on that, you can see there's a point tester class, line number 7. If you click on that, it brings you to there. So it tells you that the null pointer exception occurred in somewhere here, somewhere here in this line, somewhere. Okay, that actually helps you find out the error. So now we can realize that, okay, somewhere here, the only place where I try to get access to the attributes are P0.x and P0.y. And now you can see, oh, because in this line here, P0 is null. So I cannot say null.x or null.y. It simply wouldn't work. Okay, any questions? No? Is it clear? Are you sure? Yeah, yeah, that's good. Very good. Okay, let's go on. So let's create some new methods for us for the point class. Let's say we have methods for us to move up, down, left, and right. I'll do one of them, and I will ask you to take a few minutes to create the other 3. So let's say we want to move up. Let's say move up is going to change one of the attributes in the point class. So it's going to be a mutator, which means it's going to return void, does not return anything. So if you say void, let's say move up, okay? And then, so when you say move up, you have to say how many units you want to move up. So that's why we say, let's say double, and then units, okay? So now when we move up, we're only going to change the y value of the points. So we'd say y, you can say y is assigned to y plus units, or alternatively, you can say y plus equal units. Either way. So now I would like you to complete move down, move left, and move right. Okay. Maybe take 2 minutes. That should be rather easy. You can figure out what should be the corresponding attributes to change. So now I would like you to do this. So move down and move left, move right. Okay. And then we'll see how that works. So for example, let's say if you have P1, let's say X and Y, if P1 is here, let's say 3 and 4, let's say somehow. If you say P1 dot move up by 2 units, in this case, you're going to have a new location for P1. It is only going to change the Y value of P1. So it's going to be basically 3 and 6 as a new P1 after you move it up, right? So now, see how you can do move down, move left, and move right. Okay, that should be quite easy. Okay, give you 2 minutes to write it. And then we'll write some write some code in the tester. If you're done, you can compare your answer with mine, which should be right. If they are different, it could be that I'm wrong, because I type it quite in a rush. Have a look. Now I'm going to turn on the lights. It's easier to compare. Yeah, so these methods should be quite easy, right? Because if you think about it, it's a very simple change to the relevant attributes. Okay, any questions about these methods? No? Okay, very good. Okay. So let's try these very quickly. Just try maybe just a few examples. Just one example. So now let's say we got P1 here. It was currently it's just 0.2. So let's say according to the handouts, we would like to move P1 to the right for 3 units. So if you say P1 dot move right by 3 units. So it used to be 0.2. If we move right by 3 units, so what's going to be the new position? Any idea? So from 0.2, 3.2. Very good. Let's try that.
But don't we have to get rid of the P0 equals P0 is the line 7?
Yes, you're absolutely right. I would say let me just put it in comments and say this line here will cause a runtime null pointer. Yes, exactly. Thank you. Yeah, you can leave that line just in comments, so you can remind yourself. That's something you shouldn't do. Okay, so now let's see what the printout should be. And let me also print make some comments here. So now system.out.println. Okay, you can say here move P1 up for 3 units. Okay, so it's so you can actually track the progress. So if you do run, you'll see that P1 used to be 0020. Sorry, 02. Okay, and then move P1 up for 3 units. It's gonna change the move to the right. Sorry, you're absolutely right. Yeah. Okay, move that to the right for 3 units. It's gonna change the value. It's gonna change the x value only. So it's gonna add 3 to it. So it's gonna be 3, 2. Okay, that's correct. Okay, let's see another one. So we're gonna then move P1 up for 2 more units. Okay, so let's see system.out.println move P1 up for 2 units. Okay, and then I'll say P1.move up for 2 units. After that, I'm going to print out the location again of P1. Okay. If you like, you can actually make some comment here. Okay, here you can say it's 0, 2. And then here it would be 3, 2. And after that, it's going to be 3, 4, right? Okay, just make a comment to remind yourself. Okay, if you say launch the program again, you're going to have that. Okay, exactly the same output. So basically, the point is we are trying to print out the location of P1 in different stages after we perform different updates to the points, either move up or to move right. Okay, so we should really try to keep track of that. Okay, that's one of them. Let me see what else. Okay, we got number 7 done and number 8. Okay, so now let's calculate some distance. How do we get a distance from the origin? Okay, so now the formula is, so let's say if you have, let's say P1 is here, let's say 3 and 4, for example. If P1 is 3, 4, and then you want to see what's the distance between the origin and P1. So the formula is, well, I'm sure you know, it's 3 minus 0 squared plus 4 minus 0 squared. Or you can simply just say x squared plus y squared and take the square root. Okay, that's what you can do. Let's see how we can do it. And you can use the math class. Given that we have done some simple example last time, and you have done lab exercise number 2 last week for solving the quadratic equations, now should be okay for you. So now let's see how we can get the distance from the origin. In this case, we do not want to modify the x and y values. We just want to calculate the distance. So that means this method here should not be a mutator. It should be an accessor as well. Okay, we want to calculate the distance from the origin without changing the values of x and y. So we need an accessor method. Okay, that's the justification. Okay, we just want to do some calculation. So now we're going to calculate the distance because x and y, they are double. So of course the distance will be double as well. It's going to be a method that's going to return a double and then get distance from origin. Okay, and because we know we always have to subtract 0 from x and subtract 0 from y, it's always the case. So we do not need any extra information. So x and y should be sufficient. Okay, so now we can do the following. So now we can say, you can either say, well, let me show you the simplest way. You can simply say, I'm going to return a value here, and the value is going to be calculated by using a square root. You can say math dot square root of x squared plus y squared. So x times x plus y times y. That's one way. Let me show you another way. Or I can say return the square root of, let me just do another math dot power, x to the power of 2 is equivalent. And then plus math dot power y to the power of 2. Okay, this will also work, but you can just say x times x rather than x to the power of 2. So you can see this part here is calling the power method from the math class, so x to the power of 2. And this part of the expression here is calculating y to the power of 2 using the same power function, and then do the addition together, and then take the square root. Are we okay with this one here? Okay. Okay, that's how you get a distance. Let's try. If you go back to the point tester class, let's try. Because now the P1 has been moved to 3, 4. So let's see what's the distance from 3, 4 to the origin. So what we can do is, let's say system.out.println. You can say distance from P1 to origin is something here. So let me just do some little bit of variable declaration here. You can say double distance of P1 from origin. There's a variable here, double, is assigned to some value. So here we can call the accessor method on P1. P1 dot get distance from origin. Okay, because this is an accessor method, so when you say P1 dot get distance from origin, it's going to return a double value. Okay, and here you can say distance of P1 from origin. That's one way of doing it. Okay, I'll let you type. Okay. Yeah, this is one way. So you basically return the value from P1 dot get distance from origin and store that value in a double variable, and then print out the value that is stored in that variable. That's one way. Another way of doing this is slightly simpler. It's up to you. So let's say I'll tell you version 1, store the return value first, then print out the stored result. That's version 1. So version 1 is store the return value first and then print out the stored result in this variable here. Okay, in version 2, I'm not going to store the return value in some variable before I print it out. In version 2, I'm going to say the following. System.out.println, and then I can say distance from P1 to origin. So now I can say P1 dot get distance from origin. Okay, so I'm gonna type the comments. I will give you time. Version 2, print out the returned value directly. Okay, now you can type. Two versions. Of course, the advantage of version 1 is the value has been stored into a variable, so you can reuse that result for many times. On the other hand, for version 2, the return value was not stored anywhere. So let's say you want to print it out again, you have to call the method again. That's the difference. I can feel free to use any version you like. Okay, so now let's have a look at the printout. It's the 3 and 4. So 3 squared plus 4 squared, take the square root, it would be 5. So the distance would be 5, right? So version 1 and version 2, distance is simply 5. Okay, that's good. So now let's see. Let's define. So another one that's interesting. Let's say we have this. Okay, let me just draw this again. Let's say now we have P1 and P2, 2 points. Okay, and P2 is not necessarily the origin. Let's say we still have P1. That's 3, 4. Okay. Let me say I have a point over here, P2. Okay, let me say, let's say 9. P2 is 9, 12. Let's say that. Okay. Now I would like to calculate the distance between 2 points. What's the distance between them? Okay, so now I would like to design a method to calculate this. Okay, let's think about how we're going to use the method before we design the signature. So I would expect if I say P1 dot get distance from, and then so here if I simply say P2. And I would expect this to return back to me. You can see 9, okay, 9 minus 3 squared plus 12 minus 4 squared. Take the square root. So that's 6 squared, 36. 8 squared, 64. That'll be 100. Right? 100 take the square root would be 10. Right? That's easy calculation. So now I would expect this one to return back to me 10. That's something I would expect. Okay. So now, actually, I tell you what, I got 2 versions of method I'm going to tell you. So you do have the freedom to choose which one you like. Let's say this is version 1. Version 1 is, I simply give an objects as the arguments. That's version 1. So now for version 2, I can give you, for example here, I can say P1 dot get distance from. So now rather than giving you a objects of type points, I can just give you the x and y value. Okay, I can say now what about just 9 and 12? Okay, this is I would like to know the distance between P1 to a point whose x coordinate is 9 and y coordinate is 12. What's the distance? And the result should be just the same, right? Just the argument value here are different. So we've got two different versions of the method, right? So my point is the parameters are not always fixed. You do have the freedom to choose. But I'm now just showing you 2 different versions of the methods. They are equal, okay? Let's see how we can do that in Java. In Java, I'll show you. So now, let's say here, we want to calculate, okay, sorry, let's see that. Okay, much better. We want to calculate the distance from another point. And we have 2, okay, calculate distance without, a similar argument, without changing the values of x and y. So we need an accessor method. And now I'm going to say there are 2 versions of the parameters. It can be either a point objects, or it can be the x and y values of another point. 2 versions, okay? So there are 2 possible choices of the parameters, okay? Choice number 1, a point objects. Choice number 2, the x and y values of another points. Okay, 2 choices. Okay, I'm going to show you both. Let's see how we can do that. Okay. Let's do it for version 1. Let's do the signature first, and I'll show you the way we implement that will be slightly different. So now, let's say we're going to return the distance, which will be double. Okay, get distance from. Okay, the version 1 is going to take another points, just say points, and other. Okay, don't worry about it, it doesn't compile for now. Okay, I just want to get a signature first. That's version 1. Okay, version 1. Okay, let's see version 2. Version 2 and double, and in Java you can have the methods with the same name. That's okay, as long as the parameter types are different. Okay. I'll talk about this more. It's called something called overloading, but you don't need to worry about that now. So get distance from the same name, but now we're going to take 2 parameters rather than just 1. So we're going to say double other x, okay, and also double other y. The way we calculate the results for these 2 versions of the methods is almost identical, almost. However, the way you calculate, you gotta be a little bit careful. Okay. So now, why don't we do version 2 first? It's kind of easier. Okay. And of course, we're gonna apply the same formula. Okay. So now we can say double distance. Okay. Is assigned to, so we're going to apply that square root formula. So we're going to say math dot square root, and then the addition of the 2 squares. So now we have to say x, which is the attribute value here, right? We declare x over here. So x minus, so it's going to be a square actually. So we better say math dot power. Okay, so x. Sorry, let me just show you the easier version. You may not want to get to this complicated. So you want to say x minus other x, right? And square. So why don't we just make it naive? You can say x minus other x, multiply x minus other x. That's a square, right? And plus y minus other y times y minus other y. It's a bit long. You can change that to a new line if you like. Okay, it's going to be your square root of 1 addition. The left operand of the addition is x minus other x squared. And the right operand of the plus will be y minus other y squared. Okay, and let me show you the version where you can use the math.pow. You can say math dot square root math.power x minus other x to the power of 2, and plus math.power and y minus other y to the power of 2. Okay, so I'm going to comment out this version here, but you can feel free to use it if you like. Any questions about this method here? That's how we calculate the distance. Just x minus other x, because other x is already given. And then, of course, it's an excessor method, so this is only computation. So you're going to return the distance. Okay, that's version 2. The critical thing about version 2 is we already give you other x and other y. So there's no need to use the dot notation here. Just other x and other y already given to you. Okay. I'm going to show you examples for both versions in moments, but let's try to define them first. Okay. So now let's do version 1. version 1, we are given one parameter only. And this parameter here is a point rather than two doubles, like a x and y. So the way we actually get an x and y would be to say other.x and other.y. Because other is a point object. So we can use the dot notation to get the x and y values of other. Okay, so the way we do that is very similar. Now we're going to say double distance is assigned to. So let me use the simpler, use the square root, math dot square root, and now it's going to be addition of two things, math dot power. So we're going to say x minus other dot x, y minus other dot y. Oh, sorry. To the power of 2. Beg your pardon. And plus math dot power and y minus other dot y to the power of 2. And then we're going to return the result. Okay, I'll let you type and think. I'll give you maybe 2 minutes. Okay, think and compare the two versions here. The way we access the way we access the attributes in the current class is the same, just x and y. But the way we actually access the x and y of other points will be different. Right? In version 1, we gotta say other.x and also other.y. In the second version, other x and other y are already given to us. Okay, so these are just different flavors of defining the methods. Of course, the way you use them will be also different, which I'll show you in a moment. Any questions? Yes.
Just for my, because I keep getting errors.
Which one?
Actually,
For both? You forgot about return.
and
Yeah.
when it says it because this has the same name.
No, that should be okay. Get distance from. Get distance. I think it should be. I think it just get a make a return.
Oh.
Maybe after you make the return, that should be okay. Let's see. And if you save it. That's oh, somehow you can close these two inside the body of get distance from origin. That's not right. So these are separate methods. That's one.
Thank you.
Okay. Let's now try to use these two methods. Okay. Let's see. So now let's see how we can calculate the distance. So now we would like to do the following. Let's say we would like to calculate the distance between 3, 4, P1 from another point, 9, 12, P2. Okay? But there are two different ways we can pass P2 to calculate. Two different ways. Okay? Let's see how we can do that. So now let's first of all create a point P2 in point tester. So now let's say point P2 is assigned to new point. It's 9, 12. Okay? If you like, we can also print out the coordinates of P2. Okay? P2 is P2.x and P2.y. It's 9 and 12. Okay? So now let's see, calculate the distance between P1 and P2. So we got two possible methods we can call. Okay. So now version 1, double, I'll say distance 1. Okay. Distance P1, I'll just distance 1. Okay, just easier. It's assigned to, if I say P1 dot get distance from, so now I can simply say P2. That's version 1. Okay. Version 2, double distance 2 is assigned to P1 dot get distance from, so now I can say P2 dot x p2.y. You can see the way we use them are different. In version 1, we simply pass p2, the whole objects. Wow. To be more precise, in line number 36, we pass p2, which stores the address of the objects, which contains x and y, being 9 and 12. In line number 37, we try to pass p2.x and p2.y individually. Okay, it's different. Okay. Think about it. I can write some notes for you. So let's say when calling version 1 of get distance from method, we pass as arguments the address of a point objects. Okay, that's what this one is doing. Just p2 is the address. Okay, when calling version 2 of the get distance from method, we pass as arguments the x and y values. Okay. Okay, any questions so far about the two versions? Okay, yeah. Yeah, just two versions. Okay, so now let's go on. So now let's see what else. This one's interesting. Okay, so now we're done with all the methods in the point class. Okay, now we would like to do something interesting. We want to see how we can manipulate the point using array in the tester. Okay, what about this? We would like to have a collection of points. So now, first of all, let me do just 3 more points. Okay, so now let's say point p3 is assigned to new point. Let's say 7, 9, and point p4 is assigned to new point, and then 8, 1. Okay, just different points. And point p5 is assigned to new point, and then -2, -4. Okay. So now, let's say this is what I want to achieve. So let me show you something new. Okay. So now we want to store a collection of points. Whenever we talk about collection in this course, that means you need to use an array. So now, remember when we used to say integer array, that's how we do it. So now, before the square brackets, you're going to say point instead. Say point, square brackets. Okay. Let's say point collection. Okay. And now, let's say it's going to be a collection of, let's say, new point, let's say 5. Just make it easy. Okay, let's not do something too complicated. Just 5. Okay, and then let me do several lines for you and now explain on the board. So you can say point collection, it's an array. So you can say at index 0 is going to be assigned to the address that is stored in P1. Okay, I'll draw the diagram for you in a moment, but let's do this first. P1, P2, and 2, P3, P4, and P5. Okay, just type, and then I will draw some diagram on the board. Okay, once we finish typing, I'm going to turn on the lights. So now we got 5 points, P1, P2, P3, P4, P5. And if I remember correctly, P1 is 3, 4, and 9, 12. Okay, so we have P1 points to a point object, X and Y. And also we have P2, and that one also is a point object, X and Y. And P3 also a point object, X and Y. Be careful, otherwise I have no space. Point, X and Y. I'm going to write it over. Okay, and then we have P5. P5, and that one is going to be point X and Y. Okay, we got 5 objects, P1 up to P5. That's what we have. So now, let's consider this. When we have, let's say, this one here, point collection 0 is assigned to P1. What does that really mean? That's something we got to figure out. Okay. So now, if you have point collection, if you look at line number 48, we say that point collection is going to be an array of size 5. Agree? Okay, good. First of all, let's draw an array of size 5. So 0, 1, 2, 3, 4. And that's called point collection. Okay, so now each one of them is of type point. Okay, this particular slot here is of type points. This slot here is also of type points. Okay, more specifically, each slot is going to store an address of a point object. We're talking about address, really, right? So now, conceptually, you can think of when I say point collection 0 is assigned to the value of P1. What does that mean? That means whatever address that is stored in P1, I'm going to copy the address and store that in point collections at index 0. Okay? So the diagram is going to look like this. So now, 0 slot is going to point to wherever P1 is pointing to. Think about this, actually. Think about this one. Let me repeat again, okay? So, it's actually, this one is very important. I couldn't actually wait until, can I wait until next Monday to explain this? It's actually quite important. We need that for another exercise. Okay, let me say that again. Let me say something maybe slightly simpler, okay? Slightly simpler. Okay, put this aside. Let me say I got another 2 points. Let's say 6 and 7. P6 is pointing to here. Let's say this point. Let's say X and Y. Let me just say 10 and 12, just for example. Okay. So now let's consider this. When I say points, or draw a little bit higher. When I say the following assignments, so now when I say point, P6 is a new point of 10 and 12. Okay, that's how I set this up. Okay, so now let's see another assignment here. If I say point P7 is simply assigned to P6, this is slightly simpler than what I wrote on the Eclipse over there. Let's try to understand this one first. First of all, we know that P6 stores the address of this point object. We know that. So now we say that P7 is also going to store an address of the point object. Now we say that P7 is going to store the same address of the one that is stored in P6. So whatever that is stored in P6, we're going to copy that over to P7. So after this assignment here, we're going to have P7, because it is going to store the same address as P6. So they are going to point to the same objects. That's what's happening. Okay, think about this example first before you move on. Any questions? Please, if you got questions, it's not to complain, to say, I don't get it. Please. That's okay. It's totally acceptable. Okay, maybe I should explain one more time, I guess. Okay, that's, I'm pretty sure that's a no. Okay, let's see. Do we agree that, okay, let me just do a little bit better this time. Very important. Let's say this is 1, and this is 2. Okay, we got 2 assignments here, 1 and 2. For number 1 here, we say that P6 is going to store the address of some point objects. And this point object has been created using a new keyword. So it's going to be this point object here with 10 and 12, right? So P6 stores the address of this particular point object. That's why I draw P6 points to this object. Okay, that's line number 1. Are we okay? Okay, P1 stores some address. Okay. Sorry, P6. So P6. So now, this line here, first of all, is an assignment, right? We're trying to assign some value and store that into P7. Agree? Okay. So P6 stores the address of this point objects. And now we say that copy that address and store that into P7. Okay. Okay so far? Okay. For example, let's say if it happens that this object is in this particular memory position, point x and y, that says 10 and 12. Let me make a very concrete example for you. Let's say this memory address 00011, for example. Okay, so now we agree that P6 stores this particular address. Okay, if you think about P6, it's a placeholder for this particular address 00011. Okay, after this line number 1 here. So now we are saying that P7, which is also going to be, let me get rid of this line. So now P7 also is going to store an address of a point. Now we're saying that P7 is going to store whatever that is stored in P6. So we're going to copy this value here over to P7. Okay, so we're going to copy 00011, the same address. So now P6 and P7, they store the address of the same point objects. Agree? So now that's why when we draw, we can say P7 also points to the same objects. Yes?
P6 and P7 is same?
They store the same address, which means they refer to the same objects. Mm-hmm. They store, yes, both of them actually store the same address to the same objects. Are we okay? I can explain one more time if you like. You know, it's really, really important. Good? Very good. Very good. I'm pretty sure you're fine. Okay, are you okay? Okay, very good. Okay, so now, things get a little bit ugly. So now, how do we do 49? Really the same idea. Really the same. Okay, I'm going to wipe this out. So now remember P1 is 3, 4, and P2. Let me just put the values first before I go on. It's 3, 4, and P2. P2 is 9, 12. Okay, so now I think it's worth just making sure you get this example by the end of today. We can do lab exercise on Wednesday. That's absolutely fine. And then P3 is 7, 9. And then 8, 1. And then -2, -4. Okay, so now let's think about how we can interpret lines 49 to 53. How do we do that? Similar idea. Okay, let me wipe this out. Let's just consider one line. So let's say we have point collection. Similar idea, point collection at position 0 is assigned to P1. Okay, how do we see this? So now P1 stores the address of this point objects. And now we're going to copy this address here to the first location of this array. Right? And then if you want to draw the diagram for that, it is something like, now this slot here is also going to point to this object here. Much better? Very good. Okay, what about line number 50? We're saying that we're going to copy the address of P2 into the second slot of the array. So it is as if we draw another arrow like that. Okay, so now, similarly, like that, and like that, and also like that. So basically, you can see at 0 slot, it points to P1. First slot, it points to P2. And position 2, it points to P3. Position 3, it points to P4. Position 4, it points to P5, etc. Exactly what the line is trying to say. Okay, so now, what should we do with it? So now we want to see the debugger. So now let's try something here. If now I do the following. If I say, tell me, according to the diagram, what's going to be the output of this? If I say system dot out dot point line, I would say first point in the collection is, okay. Let me just say print, so I can separate that into 2 lines. So the first point in the collection is system.out.print line. So now I can say I can say this parenthesis plus. So now I'm talking about the first point in the collection. So it should be point collection at position 0. And I know that it is a point. So I can say dot x. Okay. Plus, comma, space, and point collection 0 dot y. Plus, okay, I'll give you time to type. That's fine. Oh, forget the plus here. Okay, type first, and now I'll turn on the lights. Okay, so now, according to the diagram, tell me something. What's going to be the output from line number 56, according to the diagram? If I say point collection 0 dot x, 3, agree? Yeah, because point collection 0 stores the address of this point objects. When I say dot x, it's going to give me 3. When I say dot y, it's going to give me 4. Agree? Okay, very good. One thing to note, interestingly, you can see p1.x and p1.y is going to give you exactly the same result because they refer to the same objects, right? Because p1 refers to this object here, and point collection 0 refers to this object as well, right? That's something I will talk in detail on Monday. Okay? That's something also when things can get tricky. But, that's good for now. Okay. One more. Let's run a loop. Okay. We haven't touched the loop for a long time, so it's now time to refresh it. Okay. Very simple loop. Don't worry. Let me say I want to do the following. Move each point in point collections up by what did I say over there? By let's say 5 units. Okay, just copy this, type this comment first, and then I'll show you what's going to happen in the diagram, and then I'll show you how to write a Java code. It's incredibly easy, actually, incredibly easy. Okay, so let's see the diagram here. So we know that to move a point up, we have to increment the value of y by 5. So now you can see that point collection has 5 points. 1, 2, 3, 4, 5. So now I would like to, this is the first point in the collection. I would like to increment its value by 5. So it's going to be 9. Somehow. And for this, I'm going to increment its value by 5, 17. And then 5, 14. 5, 6, 5, minus 4 plus 5 will be 1. That's totally the result I want to get. And remember, we defined a move up methods in the point class. So it would be very nice if somehow we can say, call the move up method on P1. So basically, we want to do the following. P1 dot move up by 5. And P2 dot move up 5. And P3 dot, you can see it's getting very tedious. P4 dot move up 5. And finally, P5 dot move up 5. So each one of them. But what if, let's say, if the point collection has 100 points? I'm pretty sure you don't want to write it out 100 times, right? So now you can see that we are trying to call the same method, move up, by the same units 5. So somehow we want to repeat this action for however many points we have in the collection. In the case where we got 5 points in the collection, we're going to repeat this 5 times. Each time we're going to have different points to call, like a different context object, right? So how do we do that? You can see that the way to think about this is P1 is basically point collection 0. We know that already, right? P1 is actually pointed by point collection 0. And P2 is pointed by point collection 1, right? P2 is actually the second points in point collection, okay? Similarly, you can have let's say PC, the point collection 2, and point collection 3, and point collection 4. So you can see 0, 1, 2, 3, 4. Seems like a loop. Okay, we can use a loop counter. Okay, how do we do that? Let's see. The code is incredibly simple, but the idea it requires quite a bit of thinking. So you can think about that. So maybe bring your question to Wednesday tutorial. Okay, so let's see how we can do that. We can say for integer I is assigned to 0, I less than point collections.length, I plus plus. No surprise here, right? Just we want to go through all the valid indices for this array. So now we can say that, let me show you 2 different versions. Version 1, okay? We can simply say point collection at position I, which can be 0, 1, 2, 3, 4. Dot, because we know point collection I is actually of type points, simply because if you look at the declaration for point collection, you can see that point collection was declared as an array of points. So every element in the array is a point. Okay, so that's why you can say point collections I dot move up 5, and you're done. That's it. Okay, that's version 1. Let me show you version 2 as well. But of course, choose either one, not both. So now you can say point P. The current point that we are looking at is going to be point collections at position I. And then we can say P dot move up 5. So this is like a version 2. Okay, we just have some intermediate variable P to store where point collection I is, and then to call that move up method on that particular points. So, but if you are more comfortable with version 1, don't worry about version 2, okay? At least for now. Okay, any questions? Really? No questions? Okay. So please study this. I wouldn't expect you to get every detail today, right? Try to study that. It's very important. Okay, final one. Final one. And then we're done for today. The final exercise will be, why don't I let you try maybe 2 minutes and then I'll go over a solution. The final one is, okay, let me write it on the board. We're still going to run the loop over the point collection clause, but now the problem is slightly different. I'll keep the diagram. So now we want to, for each point in point collection, for each one of them, move it right. Move it right, to the right, by 6 units if the following is true. If it is above the y-axis. So for those points that are actually above the y-axis, we're going to move them right by 6 units. How do we do that? So it seems like you need an if condition. So for example here, let's say in this point here, is that above the y-axis? It is, because the y value is larger than 0. In this case, y here, if the y value is above 0, so that's above, so you gotta move that to the right. And this one as well, and actually everyone is actually above the y-axis, that's okay, but write the code to make sure, because somehow we can also set the y value to be minus. Yes?
Well, I had a question because for the next one for the loop, the if statement, like we are looking at the array after updating it with a for loop we've just did before. Like, so if we wanted to do the second for loop with the original values, do you have to just say that again to that?
Yeah, let's say we just do this after we have done the first for loop. That's okay. Yeah. So after the first for loop, that's actually the value. Okay. So why don't we try one more? So can I just set here? Let me set this point to be minus. Okay. So we do have one point that is below. Okay, that's the last example we'll do today. So let's say move. Let's say the let's move the second point in the collection below the y-axis. Oh, it's really dark. Okay. So move the second point in the collection below the y-axis. Okay, how do we do that? So now we're going to say point collection second point. So it's going to be at index 1 dot move down. So the second point currently is 17. Let's move down 30, for example. Doesn't matter. So after this, you should get something like, I'll just put the comments for you. It will be 9 and then minus 13. You can double check when you go home. Okay. So now, do this exercise here, and then we're done. For each point in the collection, move it right by 6 units. If it is above the y-axis. Okay, so try to do the loop. Okay, you just need an if conditional inside the loop. See how you can do it. So you only do the move right on the current points if it's above the y-axis. But how do you check that? Okay, try that, and then I'll give you 2 minutes, and I'll go over the solution, and you're done. Because you're still typing, maybe I should turn it off. Okay. Yeah, to give you another 2 minutes, and then we'll go over the solution, which is also very easy, not too hard. Anyone done? Or on the track? Done? No. Done? Okay, don't worry, I'll go for solution.
I'm not sure. Do you have to print it for every single one, or do you have to print it
No, you don't have to print. Yeah, you can print afterwards. Yeah, very good. Okay, let's go over that. So let's still going to write a for loop to go over the point collection. So for integer I, initially to be 0, I less than point collections dot length I plus plus. Okay, this one should be no question. Okay, so now let's see how we can conditionally move the points to the right if that's above the y-axis. So if that's above the y-axis, that means the y value of the point we're looking at is larger than 0. Okay, so now we have an if statement here, and the point we're looking at is going to be point collection at index I. Right? That's the loop counter value I. And remember, this point collection at position I is a point. So you can say dot y. If that's larger than 0, that means it's above the y-axis. If that's the case, then we're going to move it right by 6 units. So you're going to say point collection I, dot move to the right by 6 units. That's it. We're done. Okay, so maybe before Wednesday's labs, so please study this example carefully to see what we have done for the various assignments and also the various object creations and the various methods. If you have questions, so you can certainly come to the tutorial session on Wednesday, which will be from 12 to 2. Okay, and on Wednesday, we'll start with a brand new exercise, which is going to use many of the concepts we talked about today. Of course, I'm going to repeat them, so make sure you're actually on the track. Okay, that's about it for today.